Hi, this video will briefly talk about Delta DXMC motion controller. DXMC means Delta extended motion controller. So you can see our software will use DMARS. DMARS is the abbreviation of Delta Motion and Robot software. This one will include POC open for motion control portion, and the POC programming will based on IEC 61131-3. And for user interface, we can use Delta HMI and communicate or go through Modbus TCP. Regarding the motion control, we use the EtherCAT DataCAT for the motion control and robotics control. This page will show three main models of DXMC series controller. First of all is DXMC-S. This one is similar to standard POC. And second is DXMC-P. This one is a panel type similar to HMI but with motion controller. The final one is DXMC-H. This one is a handheld motion controller. So you can see for the field bus DXMC-S and -P, we based on EtherCAT, and for -P, we have a 7-inch and 10-inch. Regarding the DXMC-H, is for 7-inch only, and this one is for DMC net, a Delta motion control net. For the real axis, DXMC-S can control up to 32 axis. We also have a 16. And in the near future, we'll also have the model for 8 axis. For DXMC -P and -H only in 8 axis. For third-party motions, EtherCAT Slave, no matter it's EtherCAT drive or EtherCAT I/O, DXMC-S and DXMC-P both support, but this one is only Delta internal bus, so cannot support third-party EtherCAT Slave. For the robotics control for DXMC-S, it can control more than one robot. It can be either Cartesian robot, Scala robot, Delta robot, or articulated robot. Same for the DXMC-P. And for DXMC-H, this one basically Delta can provide a standard program for the Cartesian robot. This page will show DXMC main software. I just mentioned in previous page, we main software is DMARS. So this one we use for the system configuration and Lua programming. And if customer who more familiar with POC open and IEC 61131-3, then you can use the Multiprog to do the POC programming, which also similar to Codisys platform, but it's slightly different, but the concept is similar. And regarding UI design for the DXMC-P panel type and the handheld type, also DOP100 series. This one means if you use a DXMC-S, similar to standard POC, this one, then you can use a DIAScreen to do the UI design. Here, just want to emphasize one point that Multiprog is not compulsory if you don't you do the programming in Lua, which means you use DMARS. Okay, then how to establish the connection between your laptop and the controller? So we can use either Ethernet port or USB. So you can see here, this one is for the Ethernet port, and for the DXMC-S and -P panel type, here we use the Ethernet. And you can also use a USB for -S. Here you can see the mini USB. And for -P, here we use a type B connector, which is same as our standard HMI. So here you can see if you try to establish the connection, we open the project and double click Ethernet. So you will find the default IP address will be 192.168.1.10. No matter it's a standard -S or -P, use the same IP address. This page will show you how to add on the EtherCAT slave. So EtherCAT slave, that means maybe either drive or I/O. So you can see on the top will be a Delta device, and you can use either scan or add item. If you already connect all the device under EtherCAT network, then you can use a scan device. Or if you just try to practice or first time try to hands-on or get familiar with Delta DMOS software, then you can use add item. And here you will see we have the for the first is Delta, and here we'll see a drive. Drive means a Delta VSD or VFD inverter. Then we got a servo drive, and also some third-party drive. And because here we just provide a limit model, but if you want to add on more, then you can click this one to add on third-party EtherCAT slave device through the add the ESI file. After that, you can add on the drives, and then you can create the axis. So here you can see we add on the B3 EtherCAT device, and then we can assign this one to the different drive. So for example, from axis 4 to 6, we will map to axis 1 to 3. So you can see ID 6 here, we will map to the axis 3, not ID number 3. And as I mentioned, this one is this controller is for EtherCAT for motion or robotics control. So here we just use the Cartesian robot as example. After we add on the axis, then we can create the group. And after that, we can select how many axes for this robot. So you can see we can create either 2 axes, 3 axes Cartesian or the Delta robot, and even for the Scala robot. So that just based on the axis. So if you, for example, you want to create a articulated robot, then you can add on 6 axes. And then here we put the joint number 6. So you will find a different model of articulated robot. This page will show the motion ASIC setting. So you can see we double click the ASIC, then we come to the unit. So you can see user unit we can define in the millimeter, inch, centimeter, micrometer, or in degree, or revolution, or motor PU. And PU is only for those customers who are very familiar with a Delta. So you may consider use this. Okay, and here would be the electronic gear ratio for the A and B here. Okay, so you here, for example, we put the 100K. So that means if we keep a 100K pulse, then it will rotate one turn. But today we did not use a 100K PUU. So here you just define the electronic gear ratio. That means if we put this number, so it will auto convert to the P1 -44 and 45. And then we follow by the C. C here you can see this is the ratio, C and D here. Okay, it is a gearbox ratio. So for example, you can see the revolutions at motor end. So that means motor side we rotate 10 turns. Then mechanical end, this side will rotate 1 turn. So this is the gearbox ratio. And you can also map to the exact movement of the mechanical end. over here. Second is the acceleration and velocity setting. So here you can see we can define the maximum speed, acceleration, deceleration, and jerk. So we give the different value. It will based on this page setting and convert to the RPM and the millisecond. And here just give you a hint that if we give the bigger value, bigger than its maximum, so it will show this red color to remind you that now the value is out of range. One more thing that if you tick this value, then it will follow the this setting from controller, means DXMC. If you don't tick select these items, so the ASIC setting will based on servo drive default setting. And the final one will remind you that here we can assign the homing mode over here, and also definitely you can define the high speed and creepy speed, and also acceleration, deceleration. This page will show you the multiprog variable. Here I just focus on the multiprog because in Lua we will use a POC mapping address, so that might be introduced in next time. So here you can see we define two function block. First is MC power, means to servo on and servo off, and another is MC move velocity. So here we just define like servo on. Here we define in the Boolean device. So we define in the MX 3.0. Sorry, and MX or ML. That means 3. That means we use the MX3 or ML3. That means we use the user define. Okay, so here next page will show you some more detail, and here just let you know for L real, like velocity, acceleration, deceleration, and jerk. Here is the L real, so it's a 64 bits. So if we convert to a byte, that means equal to 8 bytes. So remember, for defining this variable, you have to keep 8 difference. Okay, here I'll show you the variable rule. So as I mentioned, Boolean device is only length is 1 bit. So you can see because in multiprog the define will be 1 byte. So you can see maximize from 0 to 7, that means 1 byte. Okay, and here you can see word. We use the for the PLC input we use IX, and the Q means a PLC output, same as a standard. And here is for general purpose, so we use MX, and for the byte we use MB, and word use MW, and double word we use MD, and for real, we use ML. So you can see this one we will use a word, we will use a multiple of 2. Double word we use a multiple of 4, and real we use a long word, long integer, we use a multiple of 8. So after you defining this, so we can click here solution DMARS, then we can copy the file path. So you'll find this one my simple configuration. Then for the DIAScreen setting, here we use the DOP 100 series with RJ45, means Ethernet type, and for the controller type we use a DXMC TCP use tag. Okay, so here you can see we use the DXMC series controller TCP use tags. After that, first we click import, then we click this one, Then we paste the path from this page, the page over here. Okay. Then we'll can click this one, my simple configuration. After that, just for example, we mentioned about the servo on and the velocity. So servo on, we will select this one for the axis one servo on, and then this one will be axis velocity. So you can see it's forward and for floating. Okay, then here I will quickly show you the software portion. This is what I mentioned. So we basically we can connect from Ethernet the default IP address, and here is for the built-in I/O. So we can also do some basic testing over here. And then this is what I mentioned. You can, if you already have the EtherCAT device, you can scan from here, or you can add the item. And here we can add on the ESI. For example, if we want to add on Delta MS300 series, so we can see here. Sorry. Over here, this one is a MS300 series. And you can see this one is for Delta POC EtherCAT I/O module, and for Delta servo drive. And you can also add on a third-party device from here. And for example, if today we want to add on another B3 series servo drive, okay, and here we delete one more. Then we can add on the A6. Okay, after that, click here, and we can define this one, refer to number 4. Here to number 5, and final one to number 6. So we'll see this one will follow the node ID here. And for the node ID, we have two types. First one is a node ID. Second one is by physical. Physical means a physical EtherCAT wiring. So that would depends on the cable wiring. So, but basically, we will recommend you use the node ID mode. Okay, after that, let's see for the group. So now, if we want add on to A6, then we can see the robot type that for the articulated robot 6A6. Okay, and then we also have to configure the robot here to different A6. Okay, then here the final portion will show you the POC portion. So as I mentioned, we can click solution.dmos, and then we can go to POC portion, POC project, and then you can see this one is my simple configuration. So we can copy this page. Then when we open the DIAScreen, so we can pad this page, so we can import the tag from POC. So that's all for today. Thank you.